Okay, we're going to record what we did for the Do Now today, and this will help you understand what's going on with the LeChatelier's shifts in using heat and let's see, do we have a pressure? Yes, we do have a pressure. So we're going to start with number 1 on the Do Now, and that's heat plus the dinitrogen tetroxide is going to give us 2 nitrogen dioxides. So the shift, or not the shift, but the stress in this reaction is going to be that we're increasing the heat, and we treat the heat just like any reactant. It's a reactant because heat is on the left. So we are removing heat. No, we're increasing heat. You got this backwards. Okay, the student that brought this up has it backwards, so her group is not going to get any credit for this, but nobody's going to get sentences. So what we have is we're actually increasing the heat. Now, that is the stress. You got to get the stresses and the LeChatelier reactions totally different. So watch how I'm going to write this down. And if I can get it to switch over. There. Okay. So, whoa. Come on, Wigger. There we go. So I am saying that heat is up, not removed, and heat is going down. The other thing I don't like is I don't see what the logic was for LeChat to take the heat down. So let's go back and look at the reaction. I see heat's on the left. So to bring heat down, that means I've got to go to the opposite side. And so what I should have seen here is opposite. And opposite of the left is the right, and that's because you took a shortcut here. Okay, so that's how that one should have looked. Let's go to the next one and question. Yes? If the temperature is decreased as a stress, okay, when the temperature is down, that's the same as the heat going down. Down temperature, down heat. Okay, next up, Chrissy. Okay, what Chrissy's group has done. Okay, in number 2, we have no heat involved, but we do have, what do we call this kind of reaction? We got something that isn't going to go into the equilibrium expression. What do we call those? No. Heterogeneous. This is a heterogeneous problem. Why? Because water is a liquid. Water as a liquid does not affect the equilibrium. Okay, so we're adding oxygen, so that really doesn't make that much difference in terms of the shift. But when we add oxygen, okay, good. I see on the sheet here from the group that oxygen is shown as up, and that means that is the stress. This is the LeChat reaction. Okay, you got to keep those separated in your mind. So to take oxygen down, this is just like we've always done. Oxygen is on the left side of equation number 2 of the Do Now. And so since oxygen is on the left, opposite is going to be on the right. And this group gets extra credit. So all of you need to get out your stamp sheets so I can give you your extra credit stamp. Okay, number 3. In number 3, what we're doing is we're dealing with decreasing pressure. So pressure is one of the new ones that we talked about earlier in the instructional period. And on, even though they don't have the sheet, they kind of mimic the sheet. and he has stress is that pressure is going down. And decreasing pressure is the way it was described, so that is correct. And LeChatelier's reaction is to move it up. Now you've left out what he's going to do to move it up. Okay, so what should have been put in here is move to side with more what? Moles. Okay, so moving to the side with more moles. Now, if you count these moles up, the left side has 2 for the SO2 and 1 for the oxygen, and that's 3 on the left, and the 2 SO3 on the right means there's 2 moles on the right. So we could write this down as 2 moles here, and then we got 3 moles over here. And let's write it as moles. Okay, so now that we've got that settled, it's pretty easy. Which side has fewer moles, left or right? Fewer moles. The right side. So this is a shift to the right. And the reason you guys missed this is because you didn't go through this little logic here. So this is a right shift. Okay? And that takes care of those. And we are not going to have time to go through the